Okay, so multiplying radical expressions is just related to multiplying polynomial expressions. A monomial times a monomial is a monomial. So if you look here, my first expression says negative 3 square root of 10 squared. So we learned squaring means to write it twice. So we're doing negative 3 square root of 10 times negative 3 square root of 10. The biggest mistake you guys and gals make is you think there's two terms here. Remember, this is connected by multiplication. This is a monomial. This is like saying negative 3x. So when we multiply monomials, first of all, we do not do FOIL. We're multiplying monomials. It's all brain. We're just going to have one term as our answer. So the rule is you multiply the coefficients. So negative 3 times negative 3 would be positive 9. And then you just multiply the radicands. Square root of 10 times square root of 10 would be square root of 100. There's nothing in between this coefficient and this radical other than multiplication. So we multiply, there's the coefficient, there's the radical, there's multiplication. Now, is that the final answer? Well, we're dealing with square root. So if you look up here, 100 is a perfect square, so I better reduce this. What is the square root of 100? Oh, that's 10. So this becomes 9 times 10, which makes the product 90. Okay? Let's try our next expression. So we have negative 2 square root 3ab cubed times negative square root 6b. Again, everybody's connected by multiplication. So these are monomials. We are not doing FOIL. We multiply the coefficients, what's on the outside, and then we multiply what's the radicands, the inside. So our coefficients are negative 2 times negative 1. And that would make a positive 2. Then we're going to multiply the square root of 3ab cubed times the square root of 6b. So we're going to put one square root symbol, and we're going to multiply our radicands. 3 times 6 is 18. A has no other term to multiply by, so we leave the a. B cubed times b is b to the 4th. Now, the problem is that the final answer? You have to get in the habit of understanding. In radical world, anything underneath that root symbol has to be reduced. Just like in fraction land, you always reduce a fraction. So I now got to go through and pull out my perfect squares. I'm going to leave my 2. I'm going to start with 18. Is 18 a perfect square? Nope, it's not on the list. What perfect square is in 18? Very good. 18 is 9 times 2. Okay? Is A a perfect square? No. A is understood to have an invisible exponent of 1. Well, there's no way to break down A to rewrite it as multiplication. It's in lowest terms, so we're going to keep that A. B to the 4th, is that a perfect square? Yes, because B to the 4th has an even exponent. So now that I have it all rewritten, now I know which terms I could square root and which ones I'm going to leave. The 2 stays in front. So here we go. What is the square root of 9? Well, that's 3. It comes out. Can we square root 2? No. 2 is not a perfect square. 2 is prime. It stays inside. Can we square root the letter A? No, we cannot. A is in lowest terms. It's prime. We leave it inside. Can we square root b to the 4th? Yes. That's an even exponent. The square root of b to the 4th is b squared. Now, the problem is that's what you want to put as your answer. Remember, we're connected always by multiplication. So let's multiply all the terms on the outside. 2 times 3 is 6. 6 times b squared is 6b squared. And then instead of having 2 square root symbols, we'll just multiply the radicands together. 2 times a is the square root of 2a. And there is your product. All right, we'll do more multiplying in the next module.